stakeholders and meteorologists, climatologists across the Caribbean together. So every year we meet twice a year face to face, and every month we meet virtually, something like here, to run the models for climate forecast for the Caribbean, and we get feedback from stakeholders as to how it impacts them, what the information is like, what else they need, and further models are done to present like today. So I just wanted to show you the perspective why we are here. So we are having a local climate forum just for St. Martin. Other Caribbean islands from Jamaica, Bahamas, right down to Guyana, Suriname are doing the same. So here we are today, and based on how the feedback is, if we can have it twice a year or once a year, we'll see how we go forward. This is the first ever St. Martin's Climate Outlook Forum.
Before I go to the script, I'm going to divert a little bit from the script because it's also a moment that I can take in and reflect. Because I remember more than 15 years ago when we became a country and to create this department from what it was as part of the federal government, the former federal government, to what it is today. And to see the resources that we now have in the people and the expertise that we've built from the ground up, where before we mainly only had observers as in the department, and when hurricane time come, we would then have the meteorologists from Curacao come up, and then they would be here during the hurricane season or when there's a hurricane. And today we have our own department with observers, training observers to be meteorologists, and having meteorologists from a wide different islands and countries. You know, it brings enrichment and growth and development to the department to know where we can even do these kind of things and have sessions on climatology and not just weather in terms of the daily operations. So it's a very proud moment. Many of you wouldn't appreciate it because you might not be aware of what it was and where we came from. And I want to thank Mr. Isaac for taking the baton and Ms. LeBlanc for also leading the charge. And I want to thank you very much for bringing St. Martin's Meteorological Department to this level. So thank you very much, guys. I'm here on behalf of the minister. So let me get back to the script to address you, because unfortunately she couldn't be here due to some other engagements and commitments. But it's still my pleasure and our pleasure to welcome you to this important climate forum hosted by the Meteorological Department of St. Martin. I want to thank each of you, our valued stakeholders, for taking the time here today. Your presence speaks volumes of your commitment to safeguarding the future of our island. Most times we concentrate on the issue of weather and how it affects our daily lives, but also of significant importance is a more long-term climate forecast. As we gather here, we are reminded that climate is no longer a distant concern. It is an urgent daily reality. Rising temperatures, shifting rainfall patterns, and more frequent extreme weather events are already impacting our country, our economy, our environment, and our communities. This forum provides us with a crucial opportunity not only to receive the latest 3-month climate outlook, but to deepen our understanding of what these forecasts means for our various sectors, whether it's in water and energy management, health, tourism, agriculture, and disaster response, amongst others. I commend, again, the Meteorological Department for their efforts in translating complex climate information data into meaningful, actionable information. I encourage all of you to engage fully, ask questions, and explore how we can work together to integrate climate outlook into our planning and decision making. As a matter of fact, on that note, I will ask, because of this crux of the matter and objective, that the folks at this table from the Meteorological Department also do the presentation on the SG platform level, so that even on the strategic level, we are aware of these issues and how we can work together to integrate it into our policy perspectives going forward. Climate resilience is not the mandate of a single ministry or department. It is a cross-cutting and, as a result, a shared national responsibility. As we face the growing challenges of climate variability and change, let this forum mark a renewed commitment to collaboration, innovation, and evidence-based planning. Together we have the knowledge, the tools, and the will to shape a resilient St. Martin. And I thank you.
We just want to briefly just give you an idea. For those of you, a lot of you may know what I'm going to say, but just to give a general idea of the what we do at the Meteorological Department. This forum is a climate forum, so we're not going to spend too much time on the general Met service, but we just give a quick synopsis. This is the mission and the vision of the Met service. I'm not going to go through it. You can always get that in presentations. So this is how we set up. These are the different departments we have. We have a forecast section, observation, maintenance, climatology, and QMS administration. And a lot of persons get confused by who's an observer and who's a forecaster / meteorologist. So just to clear it, the observer under the observation departments are the ones, and that service of the Meteorological Department functions 24/7, 7 days a week, so it's never closed. These are the persons who actually observe the weather. So every hour they will go out, look at the atmospheric conditions, cloud cover, if there's rainfall, and so on, and they do a report. Okay, if there are, we have certain benchmarks, so if certain conditions change within the hour, they do what we call a special report. So while every hour they do a report, if, for example, the cloud base drops by a certain amount or visibility is reduced by a certain amount at 1/2 the hour or 25 the hour, then they have to do a special report. We generally describe them as the eyes also of the air traffic controller. So we do a lot of services for the aviation sector, and those reports would also have to help the air traffic controller in guiding aircrafts and so on. Okay, so observation, once your observation, these are the persons who observe and send out the information. Our information, all the information we send out goes to a global network that goes all around the world. This is also the information used for numerical weather predictions, put into the computers and so on. And the more information you have, the more precise and accurate the information is, then the better the outputs in terms of numerical weather prediction. So it's very, very important. So this is like the entry level. And then when you go to the next level, you have the forecasters. So the forecasters, as the term suggests, would be the persons who forecast what the weather will be. Okay, and forecast, I always have to remind people, forecast is an expectation. Although the science is getting a lot better and we're getting a lot better, it is still an expectation. It doesn't mean it necessarily will happen, because sometimes people want to tie you to a forecast, and that is why internationally you really cannot sue a meteorologist. Okay? Because of a bad forecast, or we don't say a bad forecast, but we say a forecast that burst. Because basically the scientist is doing a forecast based on data and information, and sometimes, as it's not a perfect science, you get those things. So this is a graduation from here to there. What we try our best to do when people come into the system is try to train them from here to up to the forecaster's level. But as you would understand, when we started, because of the period of training, it's like 3 years depending on what route you take. When we wanted to set up the Met Service of St. Martin, we had to get persons from the region who were already trained at that level. But our commitment is to build local capacity, and much as possible, we bring people from here, try and get people here at the local level, always a challenge, and then bring them up here. So we have, in the past couple of years, we have trained 3 persons from here to there, and then we also have 1 person presently on training in Barbados. That course is a total of 21 months. The course here is about 6 months. And then we have our maintenance department. We have 2 technicians in our maintenance department. They will take care of all our equipment and so on. That is quickly changing because with automation and everything else, persons are more into IT and so on, so we have more of that bias. But we have 2 persons in our maintenance department. Administration, very small administration department. Officially, it is just mainly administration department and a secretary. But for years now, Cheryl has been assisting a lot with administration as we wait on the change to our organizational structure. Climatology and QMS, and that's why you're here now, because of this section, which is very important, climatology, but we had to spend more time in those areas, getting those areas fixed before we went big into climatology, and that's where we're going, where we are now. QMS is quality management systems, and you might be a little bit surprised that in October last year, St. Martin, the first Met service in the Caribbean to be QMS certified. First country in the Caribbean to be QMS certified. Last month, the second country was Bahamas.
Okay, thank you.
Okay. The QMS certification goes more towards aviation. So what it says is that we are certified to provide aviation services to the airport. And that's an international recognition. There are going to be a lot of challenges because when you get the certification, it's a lot of work to keep it there. But again, I want to commend the staff, and that project, Climatology and QMS, again, is led by Cheryl, and a lot of assistance from the other staff. We're small, but we try and we work together and get things done. Slide, please. Okay, so I basically covered this, but I wanted to point out here. We are contractually committed to provide services to the airport. And that is the only revenue generating stream we have presently. In other countries, they also get revenue from things like climatology. Persons make requests for data, for engineering purposes and other purposes, and they charge for that. Here we don't have that legislation and so on. And to be honest, there are not too many requests coming for that purpose. And some of the requests that come in, it's always a government project and so on. So we might say, why not charge? But we have to look at the logistics of it and see how that can work. And then here, that's what we're going to deal with a lot today, the Climate Outlooks Bulletin, so I wouldn't say anything much on that. We spoke about the observers. We also produce a lot of marine forecasts, and we're also looking at doing more in that area in terms of working closer with fishermen and so on and seeing actively what they need, because a lot of times we concentrate a lot on the public forecast, but in terms of the marine forecast, it's generally rough seas and so on. We need to be maybe more specific and so on as we have jurisdiction for a certain area of our waters. Next slide, please. I'm just going through quickly because I know the priority here is climatology and not we. Okay, so just to look at the tools, most persons would know that we presently operate a weather radar. That was commissioned about 2 years ago. It's a very important tool for early warnings, especially dealing with disaster management and so on. It is also a very important tool for the aviation sector. So you could think of it that way, that before we had a radar, some planes would have radars that would be able to see weather very good, but not all aircrafts would have that. And also the radars in aircrafts are limited. So before, what you would find is that a forecaster would do a 2-hour trend forecast. So a forecast for 2 hours for the airport and for aviation. With satellite, it doesn't give you precise information like a radar. So with the radar now, we can get more precise information and you can get more accuracy in your trend forecasts. And I'm going to give you an example. You could have instances where aircraft might be approaching St. Martin, and because of the weather, it may have to go to Puerto Rico or maybe back to Miami. But with the radar and being more precise and accurate, you have a better idea of whether the rainfall that is reducing visibility would be only for 15 minutes and the aircraft is able to hold out west of the field for 15 minutes and so on before the wind goes through. But there's always a misconception. Radar is more short term. So you're not going to use a radar to decide what a hurricane 2-3 days out going to do or what direction it's going to. But when it comes closer, you can already see the bands and the rain bands and how intense and so it's going to be. So it's a very important piece of equipment for us. We did that project with the French, ourselves, Meteo France, Interreg, the collectivity, and so on, but we operate and maintain it. It's the white wall you see up on St. Peter's Hill. We do a lot of radioson, so that is the balloon we set up 7 o'clock in the morning and 7 in the evening. What it does is that it gets a vertical profile of the atmosphere. So as you go up in the atmosphere, the winds, temperatures, and all those things changes. So we send this up. There's a network of those stations in the Caribbean. It goes into the system and the data is available for analyzing and so on, and that's how you get a profile of the atmosphere. So when you hear persons talk, we talk about high pressure and low pressure area and upper level trough and so on. It's basically all bits and pieces of data that you put together to get that sort of information. And what you see here is that we usually have school visits, so we always put the information out to students. What month is it?
Month?
Well, they usually come.
Oh, they usually come around September.
Yeah, September, October, because I think it's part of the syllabus that around that time they do weather. So we have a lot of students, schools visiting the department around that time. So that's a picture of a school visit there. But we also encourage openly that if persons, kids, whatever, interested in studying meteorology, so they could always come to the office and get an insight. We have had 1 or 2 come and they never come back. And for the simple reason that a lot of people, when they hear meteorology, they think of public weather, the forecast that you give, or they see people presented on TV, and that's what they like. And when you tell them it's a science, and it's basically physics and maths, then that's a turn off. And that's one of our challenges in getting persons into the Met Service locally, because a lot of people, once they hear physics and maths, they kind of reverse instead of coming forward. Next step. Okay, so going forward, we get a lot of times we get requests. So, for example, there might be flooding in town, and we could get requests from insurance company, whatever. How much rainfall we had last Wednesday? And when we look at the data, it may not be significant, but there was flooding in town. That is because we measured, all our measurements are done at the airport. So now, for climatological purposes and other purposes, we're looking at now at putting in a network of automatic weather stations. So we will have better coverage of the island. We'll be able to identify microclimates within the island. And that's a project being done on the NRPB, the World Bank project. So we put in automatic weather stations, rain gauges. For the first time, we're going to be measuring sea level. Also, we're going to be doing air quality. So air quality twofold. We will be looking at measuring haze, whether you have Sahara dust or you have dust from some volcano somewhere or some other. And then we also will be looking at chemicals in the atmosphere. So, for example, when we had the fires from the dump, and so we know exactly what pollutants we would be looking at and so on. So this is the way we're going, and we're also looking at putting it at least this year. We're looking at hoping we can put in a buoy also. So that would take care of sea measurements, sea surface temperatures, and so on. All these projects here on the World Bank, this we're looking to do under CRIS, the Caribbean Risk Insurance Facility. All those will be funded. So in a nutshell, that's where we are. And just to give you a snapshot and a synopsis and where we plan to go. Just put the SG on a spot a little bit. We're hoping that by pretty soon we'll have our new building, because we're doing a lot, but we're not housed properly. So we're hoping that pretty soon it is actually on the budget that we can move into a new facility and continue doing more, because we recognize the need going forward as a small country and so on, depending on tourism and so on. The data, and it's one thing to tell an entity that our temperatures are rising, or we notice that we have in sea level rise, but where's the data? So when you go in, especially if you go into international organizations for funding and so on, you need to have that sort of data. So we're just setting up ourselves and making sure that we can do that.
Here we are talking about, we are going out first. We are going to take a global perspective. Last year, 2024, we would have heard was a record-breaking hit year for the globe. This year, the report was published about March on the global state of the climate, also the Caribbean state of the climate. So we are going to also look at the end, St. Martin's state of the climate, what we are seeing so far based on our recordings. Before we go into it, I'm going to explain a bit what's the difference. I'm blocking it? What's the What's the difference between weather and climate? Weather is what is happening now at a particular place and time. So the weather in Cahill is sunny. The weather in Phillipsburg might be raining now. That's weather. Climate now is the average of weather over a long-term period. We use 30 years average. So right now, based on the World Meteorological Organization, we are using data from 1991 to 2020, that 30-year period, as our normal. So we do all our averages based on these 30 years. So climate is a long-term average of what is happening in a particular place. So for climate, we would say the Caribbean has a tropical climate. In the Saharan desert, they have an arid climate. It's very dry. In Arctic, they have very cold conditions. So this is polar conditions, polar climate. So this is what climate is. But weather, we would say it's rainy, it's cloudy, it's sunny, and so on. Got that? Yes? Okay. Okay, another perspective. We are hearing global warming. Global warming. What does that mean? Now, there are some gases in the atmosphere. Carbon dioxide is a main one of them. We have methane, nitrous acid. These gases, they are up in the atmosphere and they act as a shield in the atmosphere. So what happens every day? The sun shines onto the earth. It heats up the earth. Then the hot air or warm air rises to cool the earth. And these gases, they absorb some of the heat. Some bounces back to the ocean. That is what happens normally so that we could be comfortable. So this is the natural greenhouse effect. So the shield above us, it absorbs some of the heat and releases some. Next slide. Now what is happening now is that we as humans produce so much of the other gases that cause the shield, which is the carbon dioxide and the others, that it is shielding so much that when the air rises, that's nowhere for it to go. It comes back down and it keeps warming us up. So the warm air cannot escape. That is how the temperature keeps rising in the world today. We produce so many pollutants that the warm air that rises when the sun shines on Earth has nowhere to escape. It goes to the ocean. The ocean is screaming at us because it cannot absorb any more of what we are sending to it. So that is what is causing the global warming that we hear about. Temperature keep rising because when the temperature goes up, nowhere to go. Okay? So when you hear global warming again, you know exactly, understand what is happening. So let's see what has been happening in the world based on 2024. The greenhouse gases that we just spoke about, they have been rising exponentially. In 2024, greenhouse gas emissions were the highest ever the world has seen. So what that causes? Temperature is going to be rising, obviously. Next, you see the graphs, all the different gases, up, up, up. None of them going down or flattening the curve. Everything is going up. So greenhouse gas concentrations. With that, you can go back. Like this. Okay, we are just saying greenhouse gas concentration rises, so does the global mean temperature. So once the gases continue to rise, we continue to throw the filth in the earth, temperatures continue to rise. Go ahead. Next one, we're going to look temperature, obviously. For 2024, on a global scale, temperature rose by 1.55 degrees C based on pre-industrial ages. That is the time when we had no factories and all of these vehicles on Earth. So the temperature in 2024 was 1.55, which is like almost 2 degrees above what it used to be. Temperature, all the graphs, up, 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 up. Next, precipitation. For rainfall, precipitation is snow and rain. Compared to the whole globe, some place it has been very varied. Some places are getting a lot of rainfall, other places are getting very little. So we had a lot of drought happening in certain areas, and we had a lot of flooding happening in others. Sometimes you look at the television and you would see some places in the United States, one side raining heavily and flooding, other side dry and bushfires. You have seen that, right? Yes. Yeah, right here too. So this is a map globally. All the greens are where you have excess rainfall happening, and the browns are dry areas. Next one. All of these things that we are going through now is because temperature is rising, the effects. Ocean water content, ocean heat content, the ocean, if the air is warm, the ocean becomes warm, obviously. So in 2024, ocean waters reach record high again. So everywhere is getting warm. Graph again, up you go. Everything goes up. So around 90% of the extra heat that is trapped by the greenhouse gases is absorbed by the ocean. But as I said earlier, the ocean can't take anymore. It's like, and then we'll see what happens when it cannot take anything. When the ocean, the sea surface temperatures are warm, we destroy our corals, which protects us when we have tropical storms. When the ocean becomes very hot, it also enhances the development of storms and hurricanes as well. So it's all of them have negative effects on the earth. Next, sea level rise. If the ocean waters are warm, the sea ice must melt. And when it melts, where does the water go? Ocean keeps rising. When our oceans rise, what happened to our coastline? What happened to low-lying islands? Everything has cascading effects. Just think about it. Just one temperature rising and has so many effects on the earth. Graph again, up. Next one is ocean acidity. Once the pH levels for the ocean has been decreasing, once the pH decreases, it becomes more acidic. When it becomes more acidic, it destroys the ecosystem, our fish, our food security. So can you see the domino effect that is going on? Yeah, go ahead. pH going down, that's the only thing going down. But when it goes down, acidity goes up. The Arctic ice, the glaciers, they are melting, causing sea levels to rise. This is the Antarctica at the Arctic sea ice, and then the Antarctica. All of them went through record low ice this year. Well, 2024. So this was a quick look at what is happening globally. Now we come down to the Caribbean and Latin America. So there was this report that takes into consideration the Latin America and the Caribbean. So it's called LAC, L-A-C. So you can see for rainfall, very varied. We had a lot of flooding happening in certain areas, such as Haiti. We had flooding right here in St. Martin, right? Last year, 2024. We had droughts happening in countries like Argentina, and closer home, Grenada had water scarcity sometime last year because of drought conditions, a lack of rain. So too much rain is a problem. Lack of it is also a problem. All this is caused by increased temperature on the earth. Temperature, this is a look at the temperature. So for the globe, taking the entire data set for the globe, there was an increase of 1.15, you remember? 1.55 degrees Celsius warmer. For the Caribbean, when you use the entire Caribbean and Latin America, the increase for 2024 was 0.9 degrees C, which is about 1 degree warmer than usual, depending on if you just extract the Caribbean alone or just the Latin America. It would be either the warmest year or the second warmest year. That was 2024. Okay? See, this one tells us about the sea level rise for the Caribbean. What has been happening, or what has been noticed, is that the sea level rise around the Caribbean is not uniform. What it is, the Atlantic side, if you look at this map, the reds the sea level rise is more prominent on the Atlantic side rather than the Pacific. You see, you have paler colors on this side. So it is noticed that the rise is greater on the Atlantic side than the Pacific side. It's about, on the Pacific side, you have like 1 or 2 millimeters per year. On the other side, we have the 5 and 6 millimeters on that side. So where do we live? On which side do we live? St. Martin. No, we are on the Atlantic. We are on the Atlantic side. So what does that mean for us? Where do we live? Yes. And then we have a lot of people living along the coast. St. Martin is not very mountainous. So, something to think about. What does all that mean for us? In the IPCC report, it is said that all this global warming, increase in temperature, will alter the intensity and the frequency of extreme events, hurricanes, floods, droughts, heat waves, and all of them. Okay, so we might not even be able to forecast them properly because this time we might have very wet conditions. Next minute we have dry condition. The variability is going to be changing so often. So we have to prepare ourselves and prepare our country for these consequences. Most of them are related to tourism. We can think of it. Some of them are related to our health, agriculture, all the sectors. That's why we are trying to bring the sectors together so we know what is most important to you, what kind of information is most important to you. And as a country, the decisions that we make for the future. How do we combat climate variability? Climate variability is the changing in short term in 5 years, 10 years. Climate change is more a long-term thing. So in 100 years, in 50 years, in decades, several decades, what the change is. So I have some examples of what we can do as a country, as a department, as a person, to help reduce the amount of the increase, to alter the increase in temperature that we are now seeing. Transition to renewable energy, we know that is, we try to incorporate solar, wind energy into what we are doing. Improve our energy efficiency, how we use what we are using. If the buildings that the government buildings that we are now putting into place, we have to think of how to save energy instead of just wasting it. Our coastal environment, our mangroves, our protection that we have, what are we doing about this? Climate resilient agriculture. We as St. Martin, we know that we do not have too much agriculture going on, but the other countries in the Caribbean provide. If they can't provide us, what do we do? What's our alternatives? So we have to think of growing more climate resilient crops. The emission, to reduce the emission from transport. Oh Lord, we have a lot of that, right? The emissions from the vehicles that we have. Can we carpool? What can we do? These are just things to brainstorm what we can do to alter the increase that we are seeing globally and in the Caribbean. Sustainable waste management, education. Teach our kids about it, talk about it. Our people those who do not go to school, the man on the ground, how do we bring the information to them? And policy and governance, our policies we set as a country to alter all of these that we have just spoken about.
Just in regards to the policy and covenants, is that the point of data collection is not there. It is a very important point, because if you want to know that's associated to climate, that's data collection. Number of houses in regards to not having the structure to be able to resist clemency is also data. You need to have those registered. So in regards to having a base on how St. Martin is affected and what St. Martin can do, is starting with data collection.
Even we as Met, data collection is very important for us. You would see in our bulletins, when we give it out later, we would make reference to different things, but we only collect data at Princess Juliana. Okay? So we would use that for the entire St. Martin, but that doesn't mean what is happening at Princess Juliana is happening at anywhere else. So we need more coverage, as Mr. Isaac said earlier, that we are trying to install order automatic weather station. In everything, you need data to back up what you have to say. Okay, we are going to look at St. Martin. What is happening in St. Martin based on what we have seen for the Caribbean and the global. But before that, I'm just going to outline the seasonality, climate seasonality. We don't have winter, summer, autumn in St. Martin. Our seasons are hurricane season, dry season, wet season, heat season. In recent years, we have a new one, heat season. Okay? So hurricane season, we know when that is, June to November. Wet season often begins around June. We have seen it creeping into May, starting in May to November. Dry season, December to about May. And the heat season is it used to be from June to October. Now we are getting hot days much earlier. So we are starting all like April. And even this year, 2025, we had a hot day in March. So we see the changes happening. Then we have the hazards to deal with: tropical cyclones, floods, storm surge, coastal flooding, fire, excessive heat. What do you see? Is there any break in the year that we don't have to deal with anything? Throughout the year, we have to deal with different hazards. So that's the situation. Next. Data collection. Reason why we are doing the network, we need more data. I can't continue to tell you what is happening at Princess Juliana and think that's what happened in St. Peter's or in Phillipsburg. So we need a better coverage. That's why we are now working on a network. Next. Rainfall for 2024. This graph shows rainfall from 1991 to 2024. What we have seen, we had a wet period, then we are having a sort of a dry period. 2024 was wet. We start going above normal. The red line shows the normal line, which is about 1,200 millimeters per year. For 2024, we had about 1,300 millimeters. So rainfall is varied. 2024 was our wettest year since 2011. February last year was unusually wet. It was the wettest February since 2000. And May and November also very wet. They were the wettest since 2014. This is a heat map for rainfall. It shows rainfall from 2015 to 2024, early up till March 2025. All the browns are showing when we had below normal rainfall. All the greens, depending on how green it is, were above normal. So if you look at the entire picture, we are having like more dry periods than wet periods, isn't it? Yes, so that's how we see our temperature varying. So we are seeing more dries than wet periods. This is 2024 again, we had 3 main periods where we had extensive rainfall. What we are saying is that the intensity is changing. In a short period of time, we're having a lot of rainfall. And some of these times are seen over here in February 7th, 2024, we had 63 millimeters in just 4 hours. And all of these periods would contribute to some sort of flooding. We know the areas that flood in St. Martin. As a Caribbean forum, we have set a threshold. 30 millimeters of rainfall in 24 hours causes flooding in pretty much everywhere. So using this as a threshold, in February, we had 63 in 4 hours. So definitely you must get flooding through that. Yeah? 24 hours. Yes, would cause flooding. That's the threshold that we use across the Caribbean. So in November, when we had all the flooding, one of the pictures there, this is Bush Road, we had 47 millimeters in 6 hours. So anytime you're having more than 30 millimeters in less than 24 hours, obviously you're going to have flooding. And from my experience, St. Martin is like 15 millimeters of rainfall causes flooding.